Well, now that we know what a fluid is, let me ask you another question. Which one of the two states of matter or fluids, liquid or gas, do you think is simpler? Well, in my opinion, liquid is simpler. Why? Well, if we have a certain amount of water and we compress it very hard, what will happen to the water's volume? It nearly doesn't change. But what will happen if we compress a certain amount of gas? Obviously, the volume of the gas will decrease significantly. So this is a very good property of liquids. That is, the liquids are not easy to be compressed. Or we can say liquid has a property called incompressibility. Well, not in all scenarios can we treat liquids as incompressible, but in most of the cases we can. In those minor cases where we cannot, I will tell you first. So basically, we can treat liquids to be incompressible. What's the merits of being incompressible? Well, this allows us to treat liquids as something called a continuum. Liquid itself isn't continuous. Water isn't continuous, right? We have molecules. In the microscopic scale, everything is made up of molecules or atoms. So if we compress a gas, let's say, the volume of the gas will be decreased. So what, in essence, are we decreasing? Are we decreasing the volume of the gas molecules themselves? No. We are decreasing the distances between the gas molecules, right? So why are liquids hard to be compressed? Because the distances between liquid molecules are already small. So it's hard for us to use compression to make that even smaller, right? So this is the reason why liquids are hard to be compressed in the microscopic scale. I said this in turn allows us to treat liquids as a continuum. So there are gaps between liquid molecules. To be accurate, the liquid itself isn't continuous. But if we do not focus on each and every water molecules, but focus on something called the fluid particles, then we can treat liquids to be a continuum. That is, we can treat liquid to be a continuous thing. So what is a fluid particle? On the one hand, a fluid particle is so small that it only contains a differential volume compared to the bulk fluid. On the other hand, a fluid particle is already so big that it contains numerous water molecules. So instead of focusing on each and every water molecules, we gather them together to investigate into something called fluid particles, so that we can say a fluid is comprised of what? Comprised of continuous fluid particles.